Is the screen visible? Hello?
Yes, sir.
Okay. And I hope I'm audible enough. So in the last week, the topics that we probably covered were gain margin, right? The frequency compensation and the filters in general, right? And I hope you all have gone through them because only then would this session be fruitful, right? So without wasting further time, let me start with the first problem that we'll solve today. Okay. So the problem is a filter is having almost constant magnitude, passband transmission with a variation of 0.6% to 6%, and the magnitude of the stop band transmission is at most 1% of the passband transmission, and we need to find the maximum gain. Sorry, let me bring up the question here, right? Let's go down. I hope the question is visible to all of you. The first, so how can we find Amax for this one? Anyone? Your variation is how much? Your variation is it is plus minus 6%. Right. How much would that translate to? I mean, it's as good as if I write it in this fashion. See, if this is my 0.94 level, suppose this is the maximum one, right? And this is the minimum one. The variation would be plus minus 6% for this case, right? What would be the lower limit for this? Minus 0.88. Is this clear? I mean, this is the maximum of a particular quantity, right? If variation is within plus minus 6%, and even in the worst case scenario, if it reaches here, the maximum for the plus 6%, then the minimum it would be around this minus 0.88 level, right? Or I should say 0.88 level. Why minus? This is 0.88 level, right? And it would be pivoting around this 0.94. I mean, just a vague idea, but I hope it's clear. Now, now, how much would that, uh, okay. So now your A max would be how much? Your A max would be magnitude of 20 log of 0.88, right? And that is 1.11 dB, right? And yeah, that is A max for you. Uh, is this clear with everyone? Okay, I'll assume a yes then. So suppose now for question two, okay. Suppose that you again have a filter that has almost constant magnitude with the passband transmission having a variation of same, right? 6 to 6%. And the magnitude of the stop band transmission is at most, say, 1% of the passband transmission. Then what would be A minimum? You found A max for this. In question two, the problem is find A minimum. Okay, how much is A minimum? For that, what is, I mean, it would be minimum when your stop band transmission would be maximum, right? And maximum stop band transmission is how much? That is 1%, right? It is given in the question itself. Maximum at most, it's 1%. So how much would that translate then? Your A minimum would be how much? It would be, let's take a magnitude, it would be 20 log of your 1% is 0.01, right? This much. And that is how much? That is 40 dB, right? Because this is 10. So yeah, it would be, since it's magnitude anyway, right? This would give how much? Minus 2. Minus 2 times 20 is minus 40. And since we are taking a magnitude, it would be 40 dB. Is this clear? Okay, proceeding to the next one. Now, was Butterworth filter covered in the week lectures? Anyone? Was it covered in the week lectures? Butterworth filter? What is Butterworth filter? In your Butterworth filter, your frequency response is flat in the pass band, right? And then it rolls off towards the zero, and uh, I mean, there are no ripples either in the pass band or stop band. There are no ripples, okay, in both. So we will have a low pass, high pass, band pass, and a band stop type of Butterworth filter, right? Depending upon the transfer function. So mm, the emphasis in case of designing a Butterworth filter is to have a frequency response that is as flat as possible in the pass band, right? And it's in fact also referred to as maximally flat magnitude filter, right? And your magnitude of the frequency response g of omega, that would be 1 by square root of 1 plus omega raised to 2n for this. I hope and I mean assume you already know this. I just wanted to uh, again review this one. If you compare this with the Chebyshev filter, whether type 1 or type 2, right? And if you compare that with your this Butterworth filter, which has a slower roll off, does a Chebyshev filter have a slower roll off, or will a Butterworth filter have a slower roll off? Anyone? What is roll off first? Your roll off would be the transition from your pass band to stop band, right? And the steeper it is, more will be your roll off rate, right? And for Butterworth filter, it's roughly minus 20 dB per decade per pole. Okay. So it turns out your Butterworth filter has a slower roll off compared to Chebyshev and elliptic filter. Because, I mean, in case of uh, Butterworth filter, emphasis is, I mean, laid more on this uh, flat response in the pass band and stop band. Okay. So let's discuss one problem on Butterworth filters. So suppose following are the specifications of Butterworth filter, right? Suppose this is a low pass filter, and suppose your FP is 20 kilohertz, right? Your A max is also given. Suppose that is 1.5 dB. Your Fs is 30 kilohertz. Your A min, suppose that is 25 dB, right? Suppose these are the given specifications of a Butterworth filter. You need to determine what is order of filter n. So determine this n, order of the filter. Please attend this one. I'll wait. Done. Let me try it out as well. What is your Amax? Amax is 10 log of 1 plus epsilon square. Right? You already know this Amax, right? How much is Amax? 1.5 dB. So how much is your epsilon? Your epsilon would be 0.642. Now, at omega equal to omega s, your Amin is what? 25 dB, right? 25 dB is what? 20 log of square root of 1 plus epsilon square omega s by omega p raised for 2n, right? That is how much? 25 over 20 log of 1 by square root of 1 plus epsilon you already computed. How much is epsilon? That is 0.642, right? Square of that, 3 by 2, 2n. Now, this would mean that your n is 8.18. I mean, you cannot have a fractional order of a filter, right? So, how much should we choose order? We'll choose it 9. Okay, immediate greatest integer. So, yeah, 9 is the answer. So, for the specifications of Butterworth filter, which would be a low pass filter, the specifications of which are given by these, right? We need to choose, I mean, not choose, I mean, your order of filter would come out as 9. Okay, so now if I use the same specifications, what would be the attenuation at 25 kilohertz? Right, suppose your equation 5 is 4 rather, right? Uh, What is your attenuation at 25 kilohertz? How should we proceed this one? And we can simply substitute omega S as 25 and omega P is what? Omega P would be this one, right? I mean F, whatever. So your attenuation at 25 kilohertz would be 20 log of 1 whole divided by square root of 1 plus 0.642, right? Square, right? Whole divided by, I mean, sorry, this 25 over how much? 20 uh, and 2n, right? N we already completed. N is 9. So 2n would be 18, right? It will be 18. And yeah, this would be that innovation. So can anyone among you compute this and let me know the answer in baby? Am I audible?
Yes, sir.
Yeah. So can you please compute this one? Verify the answer, okay? I mean, I got 13.78 dB. Okay. So now, what if the specifications are same? Hmm. And you choose this, you are interested in computing attenuation at, say, 50 kilohertz. What about that? If my filter is same, what is attenuation at 50 kilohertz? I mean, for 25 kilohertz, right, we literally substituted this omega s as what? 25. Similarly, you will substitute 50 in this place, right? And then accordingly compute that duration at 25 kilohertz. I'll directly write the answer. Okay. I mean, this is literally an identical problem, not even a similar problem, a copy problem. So the attenuation 50 kilohertz would be 67.78 dB. Please verify the answers, okay? And let me know via mail if there is any mistake or discrepancy. Now, suppose I again give you a set of specifications of a Butterworth low pass filter. Butterworth low pass filter, and your FP is 15 kilohertz, A max is 2 dB, okay, and FS is what? 20 kilohertz, and here A min is 30 dB. Oh, was it DC gain is 1. We need to find the value of the epsilon. Okay, find this. Already did this, right? Can you let me know the answer? Should I simplify the equation further for you? See, your epsilon would then be how much? It would be square root of 10 to the power A max by 10 minus 1, right? So how much is your A max in dBs? That is 2, right? So 2 by 10 is how much? Zero point 0.2. So it's 10 to the power zero point 0.2 minus 1, square root of that. How much is that? Your epsilon would be 0.764. This much, okay? 0.765. Is it clear? Yes, no.
No, sir, no clear.
Why?
Sir, E max
No, I mean, this is not
divided
email. This
between
is your voice was not audible. Can you repeat?
under epsilon equal to under root 10 के power A max upon 10
Hmm.
minus 1. कहाँ से सर ये इक्वेशन आया?
Just a second. Are you fine with this one?
Yes, sir.
Okay. Then why? Can I write A max over 10 is log of 1 plus epsilon square. Can I?
Okay. Yes, sir.
Base is 10, right?
Mm-hmm.
Now, I'll uh, I'll do this. 10 to the power a max by 10 is 10 to the power log 10, 1 plus epsilon square. Is this fine?
Okay.
Right. So
Mm-hmm.
then I can do one more thing. Right. Let me keep this 10 to the power a max by 10. What is this? If you'll go through, I mean, fundamentally, what is this first?
1 plus e
Log of
square.
1 plus, yeah, this would be 1 plus x square, right? Because this is something that you'll raise to power 10, you'll get this. And
Okay.
you're
हाँ
actually
हाँ.
raised to power this, right? So this will be 1
Mm-hmm.
plus x square.
हाँ, ठीक. Okay, okay, sir. I will.
Now, is it clear how this would
Yes, sir. Yes,
come?
sir. Clear.
Okay.
Mm-hmm.
Does anyone else have any question? Yeah, it's good. I mean, ask questions because otherwise I would assume that this is understood. I guess there are no further questions, and yes, I can move on to the next one. So far, I finished 6 questions. Now there is seventh one. Right. Seventh one is as follows. I'll give you FP. Again, this would be Butterworth low pass filter. Okay, I mean, we'll be doing mostly these. So FP is now 15 kilohertz, right? Your A max is 2 dB, right? Your FS, suppose that is 20 kilohertz, right? A min, suppose that is 30 dB. DC gain, suppose that is 1. You need to find the order of the filter. Okay, how would you proceed? See, actually, I gave you identical specifications, right? You already computed epsilon. What can you do more? We can use this one, right? That A min is given by this formula, right? And we'll be able to obtain the order of the filter, right? So if I use that, my A min is 30 dB, right? So it would be 30 over 20. Correct me if I'm wrong. Okay, it will be 30 over 20. Magnitude of log of, right? It will be 1 by square root of 1 plus epsilon square omega s by omega p, right, raised to the power 2n, right, magnitude. So if I simplify this, can I write this as what? 10 to the power 2 minus 1 by epsilon square 20 by 15 raised to the power 2n. Can I write this? I mean, convince yourself I can do this. Oh, sorry. Convince yourself that I can write it like this. Or, I mean, you can let me know if you don't think it is that. Then I'll show the steps in between. Is this fine? Yes, no? Any response? This would be how much? Since nobody gave any response, I'm now trying to compute it. Just you are curious what I'm trying to do. Trying to show the steps in between. Okay. This is log of something raised power 1 over 2. Right. I can write this log of m raised power n. I can write this as n log n. Right. And that 2 I'll take to this side. Right. It would be half of log without this square root. Right. And then I'll take this 2 in the numerator. Right. That will cancel with this. Right. It would be 20 over 15 log of 1 plus epsilon square omega s by omega p raised by 2. Is this clear? Answer. Is this much at least clear?
Yes, sir.
Yeah. And then what we can do is, how much is omega s and omega p? Right, omega s and omega p is 20 and 15 respectively. So 20 by 15 is what? My epsilon is how much? Epsilon is this. And meanwhile, I'll keep epsilon as epsilon square. I'll take care of it later. But omega s and omega v is 20 by 15. Okay. 20 by 15 raised power 2n. Right, that is how much? 20 by 15. Do correct me if I commit a mistake. I mean, I'm just doing it in hurry, right? So, might so happen that I'll commit a mistake in the process. Now what? Log of m, it's log of 1 plus some number, right? Uh, can't I write this as simply epsilon square 20 by 15 raised power 2n? Can I do this? Can I? See, there are only two options, right? Either yes or no. If you are not able to understand, or if you think there is an issue while going from this to this, let me know and I'll answer. Or do you think this is fine? It's
Yes,
completely
sir.
fine in asking questions. Is
Yes,
this fine?
yes. Yeah. Yes.
Okay. Now my counter question, how? Explain now. I mean,
No, sir.
nobody had any.
माइनस नो सर इधर -1 जाएगा ना.
Where would the minus go?
20 by 15 minus 1 1 plus e square log 10 बेस लिए.
Okay, but how would minus come into the picture? मैं नहीं समझा आप क्या बताना चाह रहे हो.
1 plus e square सर है ना. 1 plus square 20 upon 15 का पावर 2n.
Correct.
तो 1 यहाँ से कहाँ गया सर 1?
That is what I'm saying. Na? When I asked, can I write this? None of you
No.
raised any objection. Right? You should have asked, no, it should not happen.
Yes, sir. Yes, sir.
Do you know what is Taylor series of 1 log of 1 plus x?
Okay, okay. 1 plus x square.
No, it is x minus x square by 2 plus x cube by 3
3.
minus x4 by 4 plus so on. Okay.
Yes, sir.
So assuming that this is a very small quantity, which this one,
Okay.
or this x is a small quantity, I can neglect these. I can only write it as x. Okay, that is indeed the case. See, epsilon is already a small number, 0.765. Take a square of this, it would be even smaller than this, right? And then you multiply it by, say, this particular thing. I mean, the idea is that this quantity I'm assuming would be very less than 1, and I can neglect the higher order terms. I can write this as x. So if I do that,
Okay. Hmm.
it would be epsilon square. Okay, I mean, it would be this, okay? Because this is your x. So this is, okay, and 20 by 15 remains as such. Now, now. 20 by 15, what else can we do? If I take reciprocal, okay, let me do one thing. I can write this as epsilon square. This is 20 by 15 square. Can I do this? No. Okay. Should I proceed from here? Let me take a reciprocal. It would be 15 over 20, 2 raised power n. 15 over 20 epsilon square. Is this correct? I hope so. I guess we made an error in the process. Did we?
Okay, okay, sir.
Let's not use a Taylor series approximation. Okay. Let's do one thing. Because the thing is that x needs to be very smaller than 1. And I guess Taylor series approximation won't hold. I mean, even if it's comparable to 1, that won't work for us. It has to be very less than 1, this particular thing. Only then can we use that. Right. So if we cannot use that, but we can anyway do what we did previously, right? 10 log of 1 plus, or I should say directly, 1 plus epsilon square omega s by omega p. What is omega s by omega p? That is 20 by 15. Right, raised power 2n. Right, this much would be 10 to the power what? 20 by 15 is how much? 5 4 or 5 3 r, right? 4 by 3. Correct? Has to be this much, right? So then If I assume it would be 10 to the power 3 minus 1 whole divided by epsilon square, that is say 20 by 15 raised to the power 2n, then it would be, I mean, n should be around 13. I had computed it before. So I can write this as 1707. I mean, you can check it later, the calculations. It will be 4 by 3 raised to the power 2n. Okay, and then we're uh, okay, I can take then log on both sides, right? If I take log on both sides, then this would be 2n log of 1707 all divided by log of 4 over 3, isn't it? Right? Which implies your 2n is how much? 25.87. That gives n as 13. Right? N is 13 then. So what are the total number of poles then? Okay, we had to compute only this much in this question, right? Yeah, we had to compute epsilon, we did that. And for question number 7, we had to determine order, find order. Okay, let's break this question here. Find order of filter. Okay, and okay, so if order is this much, and if I keep the same specifications, what are the total number of poles then? What would be total number of poles? It would be 2 times this, right? So it would be, I guess, around 26, right? It would be 26. So then let's take another question. We can take two more questions. The question number 9 would be, suppose I again keep the same specifications. What is the angular separation between two consecutive poles? Okay, specifications of that Butterworth low pass filter. I'm not tweaking with that. I'm keeping them same. All I'm asking is, what is the angular separation between two consecutive poles? Okay, how much is that?
Pi by 13.
It would be, yeah, 2 pi by 2n, or 2 pi by uh, the total number of poles. I mean, let's take it in degrees. Okay, so whatever this quantity is, let me write it down. The angular separation between two consecutive poles, that is 360 all divided by 26. How much is that? Turns out it is 13.8 degree. Okay, so your two consecutive poles would have an angular separation of 13.8 degrees between them. Okay, now last question. If I, uh, what would be the 3 dB cutoff frequency omega, assuming that I keep the same specifications? mean, this would at least be a, I mean, this would at least be covering some specific set type of problems. And then you can build on top of them. Okay. So last one that I want to take up is what is your 3 dB cutoff frequency omega. How much is that? How much is omega naught? Your omega naught would be your omega p 1 by epsilon times 1 by n, right? I'm pretty much sure this would have been taught in the lectures, right? This is how you compute 3 dB cutoff frequency per day. So it would be, this is omega p, right? Fp was how much? Fp was this 15 kilohertz. So omega p would be how much? Omega p would be 2 pi times Fp. 2 pi times 15 kilo, 15 into 10 to the power 3. That times 1 over epsilon is how much? 0.765 whole raised power 1 over 13. Okay. And that is omega naught. Okay. So, I mean, your omega naught then would be 9.62 into 10 to the power 4 radian per second. Right. This much would be your 3 dB cutoff frequency. Is this fine? Is this clear? If you have any questions, questions of any sort, feel free to ask them. Otherwise, we'll be winding up here. I guess there are no more questions, right? So we can end the meeting. Okay. And I'll make sure you'll have access to the slides, I guess, for week 5 and week 6 by tonight. Okay. Thank you.